get started. Donnie, can I have slides? Thank you. Okay, so this is the best current operational practices track. I'm Aaron Hughes, and just moderating the track. This is open to absolutely anybody. And the spirit of the best current operational practices track is effectively to have a living repository of best current operational practices documents. So the simple problem statement here is basically that every one of these operator groups, you have presentations globally, they all get archived on their respective operator forums, usually without text and without audio. And of course, as soon as they're presented, they are almost useless because they are stale, and it's really hard to tell what's actually current, living, relevant, and of course vetted. We tried to start this as a global effort, which turned out to be a bit challenging, and decided that we would start working locally and work on a templatized version of a best current operational practices track. Leave that template available for anybody in any operational region who wanted to write best current operational practices, and of course we're working on a global process as well, so that things can be converted into global best current operational practices documents vetted by lots of operational communities. So we have moved the site list, resources, et cetera, to NANOG's infrastructure. And so now the BCOP website is at bcop.nanog.org, and there's a list there, and I'll show you a page for that as well. NANOG is now a regional BCOP repository. So we now have a new website, which, what does this do? Put this on the other screen? Yeah, awesome. Which I'm sure everybody can read perfectly clearly from back there. So this is bcop.nanog.org. It is now in wiki format. We tried to come up with something that was a little easier than our last one. So you'll see right off the main page, there are some links at the bottom here for drafts, ratified BCOPs, BCOP templates so that you can submit your own, as well as a link to the list. I did, over the last several weeks, migrate the bind.com BCOP discuss list to the NANOG list, and I believe the NANOG website's got all the right links pointing at this page and so on. And I just totally broke the last website a few hours ago, so hopefully people will know it's dead, but I'll put a redirect in there as well. So today's agenda is pretty straightforward. We're just going to go over the current BCOP drafts, and then we've decided to sort of run this layout. And by the way, I'm open to any suggestions. You can feel free to send to bcop-support@mailman.nanog.org if you've got some suggestions for any process change or standards or things that you'd like to see done to this. But we're running this as current BCOP drafts, new appeals. We're going to have a global BCOP update from Richard Jimerson of ISOC, and then open microphone. And with that, I will start with our first BCOP draft, IPv6 peering transit, and Chris Grundeman's going to give an update on that. Is this, yeah, this is the one you want, right? Do you want the text?
Yeah.
It's going to be in front of you.
So this, as Aaron said, this is the IPv6 peering, basically, BGP peering BCOP draft. And we've talked about this a little bit in the past, so it may be somewhat familiar to folks. We've talked about it on the list a little bit. And I think it still needs a little bit more content and a little bit more vetting before we ratify it. There's been some questions that have come up. So I just want to walk through the document real quick so you can see what's in here right now. I can't read that. No. So there's the standard appeal at the top, and then it goes into the background of what we're doing here. And really the idea behind this one, it's IPv6 specific, but the idea was, since peering in general, right? How to set up sessions, the filtering that goes in on that is a big part of it. We haven't done a very good job of making that standard in IPv4. There's some kind of well-known best practices, but they're not, definitely not across the board and definitely not universal. And so with IPv6, as we're all turning up IPv6, or at least have recently and don't have a lot of traffic on it yet, there's a really good opportunity to get it right in IPv6. That's why we started there. So then it dives into the BCOP itself. And the first chunk of that is establish new IPv6 only peering sessions parallel to any IPv4 sessions you already have. So the idea here isn't necessarily physically separate circuits, but logically separate connections. So if you're going to exchange IPv6 routes, use IPv6 neighbors. And if you're going to exchange IPv4 routes, use IPv4 neighbors and have two separate sessions so that there's some, you eliminate the wrong kind of fate sharing and include the right kind of fate sharing. The second piece of the BCOP is filter. And this again is a big chunk of what we have in here right now. So it starts with filtering routes coming from your customers, right? And this one, I think most people will understand fairly easily. Your customers should be, most small customers, you're going to just know what routes they're using, right? It's very easy for them to either manually or somehow update you on what routes they're using, what their IP space is, or the space you've given them, even easier, and then only allow those routes, obviously. Or if they're a bigger customer, you could potentially use something more dynamic. And speaking of more dynamic things, that's also where we want to get into filtering routes coming from your peers and upstreams. So again, same thing here, with the more dynamic filtering, you probably want to use an IRR or some way to actively monitor what routes they're using, or at least a prefix count at the very least, and filter that so that you're only accepting the routes that you actually want to see from them, and their fat finger mistakes don't cause problems on your network. And then, of course, filtering your own routes, right? So you want to protect yourself by filtering your customers' routes that they're advertising to you, and filtering your peers and upstreams routes that you don't want coming into your network, but you also want to be the good citizen and filter your own routes going out. And again, this should be something that's fairly easy for yourself because you should know what you should be advertising, hopefully. And then also installing that information, which I think is actually another section down here. So use an IRR so that other people can filter your routes as well. Right, so if you install all of your routes in some form of internet routing registry so that other people can see what you are expecting to advertise, they can filter against that and actually be useful as well there. Then we've got another section on using IPAM, which I think comes into play a little bit more in IPv6 than it did in IPv4 because you've got a lot more addresses and bits of space to deal with. So it becomes even more important to actually understand where you're handing out the space, where you're using the space within your network, and so you can feed back into that IRR and other things there. And I think there's one more section, yeah. So peering DB, right? We believe it's a best current operational practice to use peering DB so that there's handy information on your network and how to contact you in the peering database. And that way, if you do it, you can expect others to do it as well. So today, that's kind of the crux of what's in the draft BCOP. And again, I think as far as nitty-gritty details of the text in those sections can probably be hashed out on the mailing list, but other big glaring holes would be good to hear about now. I know tunneling was one thing that had come up on the mailing list a little bit, and whether there was issues there or differences there. So I'd like to open it up for any comments on, is this the right direction for a peering BCOP? Is there anything missing major? Do you like it? No? All right. All right. So again, this is on right now, all the BCOPs, because we've moved over from one website to the other, they're not in wiki format yet. That'll happen shortly, but the document itself is linked, so you can look at it. Feel free to send comments to the list, or even mark up the text and send it back to the list if you wanted to. And then, like I said, soon we'll have this in a wiki format so that you can actually beat on it a little bit easier on the wiki itself. Let's see if there's anything else. No, I think that's it. So, yeah, that's the peering BCOP.
Okay, yeah, and please do join the list. You know, even if you don't have a lot to contribute, vetting these documents is actually really helpful for the community, keeping in mind that this is not just for you. The idea being when people come and ask you questions about these things, you can go, here's a document you can use for reference. This works great for your peers, your customers, people you think are doing things the wrong way. So it's very useful to have a well-vetted document to be able to hand them and not just go, you know, hey, a guy wrote this. So please do definitely review and chime in, even if it's a +1 or a thumbs up. That's still actually very useful in this particular case. So we've got a couple of new appeals as well. The first one is on extension headers, and I don't know, Ron, are you here? Ah, there we go. Okay. Oops. Yes. There we go. So I'm just going to change the display to mirror so you can actually see this. There we go.
Page down. Okay, Ron Bonnick again to rant about IPv6 extension headers, this time IPv6 extension headers in general. IPv6 extension headers can be arbitrarily long. They can be kilobytes and kilobytes long. A modern router, we're talking about a router that forwards at a fairly high speed, ASIC-based router, has to do one of two things. Either pull the entire header chain onto chip and parse it, or pull part of it onto the chip, realize it needs more, and pull more onto the chip. One way or the other, it has to do that. If the header chain is reasonably long, so it can do that pull using a reasonable amount of clock cycles, you can build an ASIC at a price that you want to pay. If you have to deal with an arbitrarily long header chain, the ASIC is going to be a very expensive animal. It's going to be more expensive than you want to pay. So the question is, do we really want to support header chains of arbitrary length in IPv6? Well, there are two things to consider. One thing to consider is how much are you willing to pay in ASICs to parse a header chain of arbitrary length? And the other question is, why is it you want a IPv6 header chain that's 22 kilobytes long in the first place? I could see a lot of ways you could cause mischief with such a header chain, but given that we don't include the ESP or AH headers in the header chain, I can't see a real use for wanting a 10 kilobit set of extension headers. So, what do we do? Well, one thing we can do is write a BCP saying, we're going to pick an arbitrary length for the maximum length of a header chain, and in this header chain, we're going to not count the ESP in that chain. We're going to pick that length, and if we see a packet with more extension headers than that, we're just going to drop the packet. And at this point, I'm looking for community feedback on that. Is that a good thing to do, or is that a bad thing to do? And I will assume that silence is people reading their email.
Randy Bush, IIJ. Why do I want more than one?
Okay, there is a question about what that arbitrary length should be. 0 is a candidate.
0, I want the encryption header.
Well, actually, I'll argue that some might be useful in the future. There might be some destination header. There might be...
IPv6 is absolutely full of things that might be useful in the future,
Okay.
which is help guarantee that IPv6 does not have a future.
I was going to be thrilled if we got a small number like 200. 0 is really good.
No, I asked why more than one.
To be honest, I can't give you a good answer.
I do want one.
One
right?
byte.
Encryption header.
Oh, okay. You're talking about number of headers, not number of bytes in the header.
Correct.
Okay. The proposal is about number of bytes in the header, and I'm saying we don't count the encryption header. So the
Why
encryption
is the
header can be as
proposal
long as...
about the number of bytes? It's not the way we think of these headers. I have sympathy for you as a router vendor inversely proportional to how much I pay you. But I think of it in terms of headers, not bytes. And why do I want more than one?
Okay, so the alternative proposal you're saying is deprecate all headers except for ESP.
Well, yeah, I'll settle for that.
Okay. I think we probably need the AH also.
Bad to use AH. AH is bad. But that's why I said one, not which one. I said I wanted the encryption headers.
Okay, one or the other header.
Yeah.
That's actually a way to dice this that might work. You can have exactly one extension header.
Well, not only that, with the sausage machine politics of the IETF, everyone will think they're getting their header. Damn fools.
So Warren Kamari, and I'm still too short. One issue with allowing just one is then you could end up with one arbitrarily long extension header. So you could have one extension header that happens to be, 1,200 bytes, and suddenly your router needs to suck it all onto chip.
If the router vendors want to put some reasonable limit on the byte count, I can survive that experience. But what I think of is extension headers, not bytes. Right? And the AH and ESP and all those are short headers. So I'm not worried about 20,000 bytes. But I can see that you might be.
See, from the ASIC's point of view, if there's
I'm not-
3 headers that are combined 100 bytes long, we can deal with that with today's ASICs.
Yeah.
So Warren Kamari again. We were expecting this to be somewhat controversial, or that people would be wildly in favor of it. But we don't seem to be getting a huge amount of feedback in either way. Do people just not care? Or is this so obviously the right thing to do that we should just go ahead? Or is email more interesting at the moment?
Jim Warner from the University of California at Santa Cruz. No, email is not more interesting right now. It just strikes me that this is an attempt to change a protocol through a best current practices process, and it just seems like the wrong way to do it. If there's something wrong with the protocol ought to be fixed. Best current practices is something different than protocol modification.
Randy, again, I presume that's what you were doing. You're not, seems to be something popular going on in the internet and ISOC and all that of publishing best current practices. I think that's a great B-arc. But this is a protocol change and I have no problem with it. And my real question is, the real IPv6 folk in this room, if they go back to the IETF and say that they have heard from a segment of the ops community that there is benefit and no objection to chopping this back, now's the time to whine.
Exactly. If I hear that, there's support in this community for updating 2460 to restrict extension headers, the draft will be written in a couple of weeks.
So, Warren Kamari again. So this was sort of a double-headed effort. We actually have a draft in the IETF that's sort of proposing this, and it's an operational draft that outlines the problem. What we would like to be able to show is that operators actually think that this is a real issue. And so if there's a operators document that says, in general, we drop these, or it's a best practice to drop these, we might be able to get people to. Sorry.
Walter Ames, LA Telecom. Aren't we presuming now that we're trying to fix a protocol problem with iron, and that don't we presuppose that these frames can only be switched in ASICs, and if they fall outside of something, we can do something else other than making the operator's decision to drop them or not? I mean, you're making an all or nothing argument. I'm not arguing for either one. I'm just saying that's the argument you're making.
Jeff Oz, Juniper. You also are going to need to have router alert in there. Otherwise, you're going to have things that depend on it, like multicast.
RSVP and IGMP, yep.
Yep, so it's not going to ever be just one. Although, really what you're saying is, this is a complicated mechanism. We're stuffing TLVs in front of routing headers in front of the packet. This makes it a mess. And something I would like you as operators to think about for this sort of problem is that if you don't have some sort of extensibility mechanism built into your core protocol, when it comes time to add the next feature, your choices are use the extension mechanism, figure out some way to make it scale in your silicon. And that's the whole mess that we're dealing with here. It's completely arbitrary crap right now.
Well, I think Randy's proposal, there are two proposals floating on the table. One is you can have as many extension headers as you want as long as the sum of bytes isn't bigger than some number that we choose here. The other is any given packet can have exactly one extension header. So you can have a router alert in this packet, and you can have a destination header in that packet, but not both. That one might be problematic.
The other half of it is if you don't decide to allow some level of extension mechanism in V6, that means that eventually you're going to have to say, we're going to just have to do this all over again for whatever that next cool feature is in IPv9.
Scott Librand, Limelight Networks. What I'm a little unclear on is who's going to be doing the dropping and under what criteria. I've heard stuff about my ASICs can't handle it, so that would seem to imply that ASICs that couldn't handle it would be doing the dropping, but we're here in a best current operational practices forum talking about whether operators want to drop them. I'm not entirely clear if we frame the discussion properly in terms of whose call this is. I'm not opposed to doing some dropping of these things. I think preserving extensibility in the future is good, but if it's just a matter of operators going forth and doing things in configurations like we do with /24 prefix lengths and other things, and V6 prefix lengths, I think that's less of a problem than changing the underlying protocol, because it's a lot, while it's baked into a lot of people's practices, it's not something that's impossible to change. So I guess if you could touch on the question of who are you asking to be doing this dropping? Is it routers? Is it operators? Whatever. That might help clarify things.
Well, there's a chicken and egg problem here. If we write a BCP that says operators may drop these packets by configuration, someone in the IETF leaps up and says, how dare you drop valid packets? So, on the other hand, if we change the IPv6 spec to make those packets now invalid, now we have the problem of, how we've changed the spec and you're dropping traffic that was valid you've made traffic that was invalid yesterday valid today. So somehow we need consensus from the operation community that it's okay for operators to drop it, and we need to go back and change the spec too to say that these packets are now invalid.
So I would take the analogy of prefix lengths and apply it somewhat similarly. It's perfectly valid to have a /127 route in BGP. Operators are no way on earth going to accept that. So I think some sort of guidance that says, if you are so crazy as to do a 2 kilobit packet or 2 kilobit extension header, operators are likely to drop it currently if they want to. That is not problematic from my perspective. I would say that if we were to go and make such things invalid in the protocol, then we start to run the risk of constraining our ability to do future extensibility. So I'm perfectly fine with making it possible for operators to drop things beyond a certain length that's relevant to current capabilities in current hardware, with the understanding that that threshold will evolve organically as the ASICs change.
I hear what you're saying, but I think, is that exactly the opposite of what the fellow sitting to your left just said a while ago at the mic? Or, let's say your left, fellow with the white beard, I'm sorry, I lost your name.
Are you talking about Walter?
Yeah. Is that the exact opposite of what you just said?
I wasn't actually making an argument either way. I was trying to understand your argument in the sense that it sounded like a very all or nothing concern. I mean, right now, today, we deal with features in V4 that ASICs don't handle, and they get punted up to software. Now it's ugly, and it won't work at wire speed, but that's what the argument I thought I heard you making. I thought you made all or nothing. It either does it in the silicon or we change the protocol.
I'm not quite sure I'm understanding the question.
So it seems that there are three options here, possibly only two of which were being discussed until now. There's my router can't handle it in ASIC, therefore my router should drop it. There's this thing should or should not be completely allowed in protocol, and therefore it's going to be binary. And then there's this weird middle ground of beyond a certain level of bytes or whatever, this thing might cause problems, so some people might drop it, and it might not get through. And that seems to be the ugly, messy reality of our current internet, is that when things are too big or otherwise not handled by equipment, they get dropped. And that doesn't fit in very nicely to the neat protocol specifications, but that's what operators deal with all the time.
Yeah.
Brandon Ross, Network Utility Force. I think the nature of best current practices is that they should be somewhat non-controversial. And I'm sitting here torn about this idea, whether this should be a best current practice or not, and coming to the conclusion that I don't think it should be, because it's too controversial, and I think there's too much we still don't know about how V6 will operate in the real world, and certainly putting the list restriction on. And by the way, I feel for the problem. I really do. Like it's a big problem, but I'm not sure that it's clear what the solution is, and I'm not sure that it's clear that we want to put a best current practice out there that may get widely implemented and then have to be backed out someday, or worse, we can't back it out someday because it's so widely implemented and we have to go make up other stuff.
Randy Bush, IIJ yet again. I think, I disagree with that. We've gone through this discussion on /19, /22s, /48s, this is and that. And this is another case of a limit to what is, I think Scott phrased it well, 127s versus. I believe I have to support your original argument that it should be byte count, not number of extension headers. That's the actual resource I'm facing. That's life. Unfortunately, extension headers are an unordered set. That's life in the big city. The creator should have thought of that when they wrote it. And I know that I shouldn't try to announce a 32, a IPv4 prefix that's longer than a 24 and expect it to get anywhere. And I shouldn't announce anything longer than a 48 and expect it to get anywhere. And there are all the silly things I can't do in DNS, even though DNS protocol, when you go back and read it, is pure 8-bit clear. Right? You can have a dot in the middle of a name. I don't mean as a separator, right? So we have these operational practice restrictions we live with. And so I'll go back to agreeing with you that it is a byte count issue, and that probably a current practice statement is the place to do it. We agree, that I'm telling you that due to the fact that I don't want to pay a ridiculous amount for an A6 swap and to upgrade for this stupid reason, that just want to warn you that I'm not going to take any extensions bigger than 666 bytes.
A well-chosen number.
Matt Poundset, Affiliates. I kind of agree with Brandon. I think it's going to be tricky at this point because it doesn't sound like we have a lot of operational experience to draw from to say, we can't do this. But it doesn't sound like there are a lot of operators who've come forward to say, yes, I'm dropping that stuff, so don't do it. So probably I think the best you can do at this point is to say, operators may drop this if you insist on having a very long header, or if you insist on having a very long list of headers. Be aware it may not work, and leave it at that.
To partly echo what Matt just said, best current practices and best current operational practices describe things that people are actually doing. They don't prescribe what people should be doing, except to the extent that everyone should be doing the best current practice. So therefore, I would think that the next step, if we think this is a problem, is for operators to decide to start dropping them. If that occurs, then we can describe that in a best current practices document. But otherwise, I think trying to describe it before anyone is doing it kind of makes a mockery of this being the best current practice, because it's not current practice.
If I can jump in for 1 second, I think there may be two possibilities for a BCOP here, right? One that Scott's talking about is the BCOP of dropping packets that have header chains longer than X bytes, right? And again, I agree that that's not something that's potentially not something that's in practice already. So perhaps documenting it as a best current practice is unfeasible at this moment. But the other side is telling people not to send packets with long header chains is the alternative BCOP, saying that there's hardware out there that can't support this. And so if you send these packets, they will probably be dropped, not because of policy, but because of hardware. And so the BCOP would be the inverse, which is don't send packets with headers longer than X. Right?
I don't tell you not to send a prefix longer than /24.
And if you ignore it and I drop it, then
I'm just
we're good
telling
to
you,
go.
I'll drop it. You're welcome to send it. Wouldn't stop you, wouldn't think of it, right? But Ron, what happens to a ridiculously long one in some arbitrary vendor's code today?
Well, not speaking for any arbitrary vendor in particular.
It's dropped.
Sometimes forwarded, sometimes dropped, depends on the hardware platform.
So the statement that it's not dropped today is false.
It's certainly not
So-
forwarded ubiquitously. How's that for vendor dancing?
I took my shoes off. I'm standing here in my socks. Have some sympathy, Ron. So therefore, I think, picking a nice random number would be good for all of us. It would send a message to the router vendors to support at least X. Do you know what they're supporting today? I'm not asking you, Ron. Does anybody else here realize that if they make an extension chain longer than X, it is likely not to make it to the other end? Right. So wouldn't you like to see a document with that number in it that you could be somewhat confident that it would make it around? I would. And the company I work for doesn't have that much experience in IPv6. And I don't think we would miss it.
So Warren Kamari again. The situation's actually even more interesting than that in some hardware. in some sets of devices, if you create a filter that only allows, TCP port 80 as an example, if there's an extension header which appears between the IP header and the upper payload, the router just blindly accepts it, whether or not it is port 80 because it can't look far enough into it. So instead of the obvious safe fail, it just passes the packet blindly.
In all fairness, Warren, some hardware platforms do that. Some blindly drop the packet.
Both ways.
It depends on your favorite platform, and the number of bytes depends on your favorite platform. So, yes, I believe what Randy is saying. It would be really great if we all specified a number of bytes that we're pretty sure works on everybody's platform.
No, I don't know. Have you asked the vendors of your equipment what they are doing?
Warren Kumari, yes, I have, and the answer is complex. Because of course, as with many things, it depends upon which line card, which software version, which particular engine is in the line card, what the flavor of the day is, what the mean byte phase is.
And you don't answer, well, okay, this is not usable rubbish?
Been there, done that, they offered to sell me new routers.
Those damn vendors. Do we have consensus that it would be a good thing to put a number on the wall that everybody should?
This is Scott. This sounds like something for a BCP, which means IETF, not a BCOP, which is here, because this is a thing that router vendors are doing for purposes of getting around router limitations, and operators should have input on whether you should be doing it, which I think you're getting now, and I think the consensus I see is, yeah, sure, go ahead and do it if you need to, but I don't think it needs to be defined here in a BCOP at NANOG.
Okay, and
If no operator has any particular wish, if there is anybody who wants to do something specific and knows what his minimum requirements are, that would be really nice to be aired here and in the IETF.
Agreed, but I don't think you're going to get much more input than what you've gotten today from this community. So go do the BCP thing in the IETF, and we know how to participate in that process too.
oh, first slide. Back one more. Yes. Title of a BCP. So, show of hands, if this were to come up as a PCP, we pick a number that we think is reasonable. Support in this room for a good idea to do, show of hands. And that's enough to get me off the stage and us all on the way to a bar.
Thank you, Ron, and thank you for the feedback to Ron's presentation. Okay. So we've got another new appeal. This is going to be IPv6 security myths and presented by Chris Grundeman. There we go. All right.
All right, thanks. So what I've done here is this is not prepared as a BCOP yet, but I was asked to put together some slides on IPv6 security myths at another conference a few weeks ago, and figured that IPv6 security in general was still kind of an unknown quantity for a lot of folks, but that there are experts out there who have laid out some very good best current practices or ideas on how to mitigate security in IPv6, which is many of them are a little bit different than IPv4. And so what I want to do is just I'm going to run through this slide deck much quicker than it was meant to go through, just to kind of highlight some of the things that I think are interesting, that might make it into an interesting BCOP, and then maybe go for some conversation after that. So one of the first myths I think that comes up is, I'm not running IPv6, so I don't have to worry. And debunking that, I think, is important, right? There are applications that already try to run IPv6. There's auto-tunneling mechanisms. There's a lot of reasons why it is not true that just not turning on IPv6 keeps you protected from IPv6. So that would be one piece of the BCOP, right? That protecting against IPv6 is now something you have to do regardless of whether or not you think you're running IPv6. And then the next big one that I think a lot of people still propagate is that IPv6 has security designed into it. And the truth is that, you know, IPsec maybe was written for IPv6 originally, but it's been backported to IPv4. And the fact that IPv6 mandates IPsec as being available doesn't mean that you're going to use it necessarily. So there's obviously some room for BCOPs around, you know, actually using IPsec and actually using the tools that are provided in IPv6, because otherwise it doesn't actually provide any more security, right? Another piece is that IPv6 is already fairly long in the tooth, even though it is just now being deployed. One of the things, like we just talked about, is extension headers, right? So I think I'll gloss over some of this because there's a lot of problems with extension headers that I think can go into security. Obviously, the RH0 is a big one that I think most folks know about. It has been deprecated, but there still may be some operational practices around ensuring that old gear that still can use it doesn't. The hop-by-hop options header, again, is another extension header that's, you know, kind of inherently evil in some ways. If you want to use it to do low bandwidth denial of service attacks. And again, there's an IETF draft on that threat, but again, mitigating it may be a good piece of a BCOP. And then kind of what the last conversation was about specifically, which is just the fact that, you know, using huge extension headers or lots of extension headers or invalid extension headers can cause all kinds of neat problems on routers and switches across the board. And then another piece of this is separate is router advertisements, right? So if someone has physical access to a network, they can use neighbor discovery to do some fun things with renumbering hosts, redirecting packets to themselves to become a man in the middle. And again, there is an RFC that documents the threat, but perhaps a BCOP that outlines how to mitigate the threat in your network would be good. Because that RFC does list some possible solutions, but I think that getting actual operator feedback on which solutions are working and which ones work in which scenarios, and maybe even some configuration examples of how to do this across, you know, various types of equipment would be interesting. And then beyond just the router advertisements, forge neighbor discovery in general, and then there's ICMP redirects, which work just like IPv4 redirects. Another piece that may be worth mentioning in a BCOP about IPv6 security is that changing from IPv4 to IPv6 doesn't do anything to a lot of attacks because they have nothing to do with the IP layer at all. So just that as a reminder. Another piece of the transition from IPv4 to IPv6 as far as security is concerned is there's still a lot of folks who will tell you that because you don't have NAT on your IPv6 router for your enterprise or your home, you've lost security. So confidently stating that somewhere that can be pointed to may be important, that stateful firewalls are the answer, not NAT. And then network scanning is another big piece that again, I hear this a lot that, oh, well, you know, you've got 180 octillion addresses on your LAN, so there's no way it can be scanned. And there's a lot of very smart security researchers that have shown this to be complete malarkey. There's a number of ways that IPv6 subnets can be scanned, mostly because of the way people are deploying IPv6 networks, right? So if you use DHCP and you just number sequentially from the bottom, well, I can still scan the first 100 or first 1,000 addresses. It doesn't matter if you have 180 octillion addresses in your /64 if you've only used : 10 through : 100. Also, Slack addresses are introducing the MAC address, right? So you can search for specific vendor types. So that narrows you down quite a bit if you're looking for, you know, a specific type of vendor. And then also there's 6-to-4 ISTAP trade all the tunneling uses well-known addresses, which allows you, again, another area to focus in on if you're doing network scanning. And then manually configured addresses, so all the addresses that spell names and that do fun things like that can get scanned fairly easily. And then once you've got access to a local node, you can use multicast and neighbor discovery to find everyone else. So all you have to do is find one address, right? So the server that's : dead beef or whatever now has given you access to the entire network once you've exploited that one device. And then there's also application layer protocols that can leak out addresses that'll, again, give you that one address that you need to leverage into the network. Privacy addresses is one potential solution to this problem. But there's, again, that may be even a whole separate BCOP on how to use them, when to use them, how different vendors have implemented them, and what that looks like. And then this part just talking about some of the tools that are already available. So again, plenty of information out there to reference into a BCOP. I think a lot of this work has been done as far as determining where the BCOP would lie. Just hasn't been kind of brought into one area. The last piece here, I think this is one of the last myths, is that there are some fairly major differences actually between IPv4 and IPv6, right? It's not just 96 more bits, it's not just a longer address. If you're doing things like ACLs and things, right? So if you're doing anything in systematically, right, and you're searching for 32-bit addresses with periods in them, those searches no longer work. If you're looking for IPv6 addresses, right now you need 128 bits and colons. There's hex characters in there which can throw off all kinds of things. So if you're doing logging or grepping filters, or writing filters or grepping logs, there's lots of issues there that are things that are different now that we may want to document. Like having multiple addresses on each host. So again, from a logging perspective, and how do you parse logs, and how do you identify users, and how do you identify sources and destinations of attacks, you can move addresses and not move hosts, right? And then the last thing is kind of parlaying off of that is IPv6 filters. I hear over and over again, just, you know, configure your IPv6 filters just like your IPv4 filters and you'll be fine. But that's not quite true. ICMP is actually required for IPv6 to operate, right? So in IPv4, a lot of times you just block all of it. And if you do that in IPv6, you will break neighbor discovery, DHCP, many other things. So there's at least a few of these ICMP messages that you need to allow. And some firewall filter example. And then the last part of this presentation probably doesn't matter. But then the last myth was that there aren't any security BCPs yet, so I think we could rectify that. There are some, but a lot of it's very broad, very general, and very, very long, lengthy documents, like the NIST document, right, which is like 120 pages or something, which is good, but I think having some focused operational experience written down would make sense. So at that point, I'd like to open it up and see if any of that makes any sense as a starting point for a new IPv6 security BCOP.
Mics are open.
Jeff Handel, Louisiana State University. There were several slides you had on there about not tracking or not worrying about tracking. But for us, tracking is very important. I still need to know who a user and what IPv6 address they're doing. So how are we looking to address that? Whether you run DHCP v6 or Slack.
Yeah, so I think, well, that's a good question. I think it's something that should be explored further. And it depends, right, on your environment, I think. But I was looking at it more from a security perspective of not necessarily not being able to track the users, but the idea that you can find them, right? If you just have a DHCP pool because you want to use DHCP and you have a block of addresses you're going to assign to your clients, then that block is exploitable potentially. And it's not that that's any less secure than IPv4, it's just that I think people...
Some of the documents that are there, as interpreted by my security department, come back to me as an operator as something that looks very brain damaged.
That's fair. And to those last 2 points, I think there is a security track going on right now. And so these were the slides that I had available to me that I used kind of expediently. So yeah, I wouldn't suggest that the BCOP itself was a myth buster, but that using some of the busted myths is a place to start with. And I also believe there is someone in that security track who may have some of this already written down as a place to start with. So just looking for feedback on whether or not to pursue that.
Okay. Thank you, Chris.
Thank you.
Right. Okay. Now we're going to have Mr. Jimerson give an update on global BCOP process. You don't have a slide for that?
Thanks, Aaron.
Put that up for a moment.
Hello, my name is Richard Jimerson. I'm with the Internet Society. A couple of months ago at the last NANOG, Jan Zors from the Internet Society came here and talked to you about a global best current operational practices idea. Basically the idea that originated here in North America, where you're documenting best current operational practices. You actually have a pretty good effort underway, and judging by the number of people in the room here, there seems to be a lot of interest in it. The idea was to go around to other operator groups around the world and talk to them about putting together similar efforts inside their regions. Now, some of that already exists in some of the other regions, but just not in a very formal way. But basically the aim was, and by the way, NANOG was the first group that we talked to about best current operational practices on the global scale from the Internet Society. Our intent was to go around and speak to operator groups and to build some momentum behind actually building out a global process for recognizing the regional best current operational practices documents as global best current operational practices documents. We wanted to gather feedback from the communities around the world and to come back and actually have a proposal in the third quarter of this year about a process. Well, in doing this work, Jan Zors has been traveling around to many operator groups. He's been on the road pretty consistently for the last 5 months, and he has a few more events that he has yet to go. But we've had a very resounding set of common feedback coming from the community. Now, a few of the elements that we had proposed when we came here earlier this year, one of them was that we were offering up the Internet Society as a potential secretariat for documenting global best current operational practices, recognizing the regional documents into a global series, and stated that there are a lot of different ways that that document series could exist. It could exist as a document series wholly owned by the operator groups collectively. It could be a document series that was created underneath an IETF process. There are a lot of different ways that it could be done that was described. And we had also described putting together a global proposal to actually put together this process of bringing people together from all of the different operator groups and creating this global series. Well, we didn't hear what we expected to hear when we went out and we talked to everyone. Now, one of the first things we did as the Internet Society is we decided that it should be an operator that actually helped us build this work inside the Internet Society. And we brought on an operator, we brought on Jan Zors to do that work. I'm sorry he couldn't be here with us today to talk to all of you, but I'm stepping in for him and describing what's happened over the last couple of months. And the feedback that we've gotten is, number one, all of the operator groups that we've talked to have said, we don't want this to have anything to do with the IETF, at least in the early stages. We don't want you putting together some sort of process and asking us to participate in it if it means that brings these documents into the IETF. We've heard that loud and clear. And we've also heard from many of the operator groups that we've talked to, and most recently in the RIPE community, where there was a BOF on this topic, that there's very little interest in coming straight out of the gate and creating an actual global process, a process-heavy, top-down sort of system where we could recognize these documents. And instead, they've asked us to do a few different things, and we're actually changing our strategy. Jan Zors, inside the Internet Society organization, has said that the way that we set out to do this in the very beginning, a couple of months ago, was probably wrong, and he's actually convinced us to change pace a little bit. So what we're going to be doing as the Internet Society with this is we're certainly not dropping interest in best current operational practices. We're very interested in it. We think they're very important. There are hundreds or thousands of operators around the globe that do not participate in events like this one. They don't go to RIPE meetings, they don't go to NANOG meetings. It's either a resource issue or it's a knowledge issue, or there might be something else that's standing in the way, but they simply don't participate. We want them to have the benefit of these best current operational practices that are discussed in forums like this one, that are being documented under NANOG right now, and that are going to be coming up through some of the other operator groups, we hope, very soon. So what we're doing is we're going to continue out on the road. We're going to be getting best current operational practices topic on the agendas at many operator groups as we can going forward. We're going to be talking an awful lot about the processes that are currently in place in NANOG, some of the processes that have been placed in the RIPE region and in other places. We're going to share that information with people. We're going to encourage best current operational practices work at the regional level, and we're going to offer any sort of secretariat service or any other type of facilitation service we can to help get those off the ground inside those regions. And instead of coming at you with a proposal in the third quarter of this year saying, we're the Internet Society and here's a proposal on how we can help make this happen, what we're going to do is simply start documenting everything that is happening inside the regional operator groups, and to continue going out and trying to get more of that activity going. And then perhaps sometime in the future, if the operators ask us to do it, then we'll put together something more formal and have a formal global best current operational practices repository. But for now, we're just going to be pointing to everyone's work going on right now inside the NANOG process and in the other groups that we're doing, and we're going to be putting our resources in to conducting outreach inside the operator groups, trying to get best current operational practices conversations started where they're not already happening, and perhaps work forward to be able to create a document series later, but it's not something that we're going to try to charge hard with here in the next couple of months. So with that, that's the update. I've channeled Jan George best that I can in collecting his feedback and reporting it back to you, and I'm happy to take any questions on what we're doing inside the Internet Society in terms of best current operational practices right now, or what it is that we may do going forward. Randy, yes.
Randy Bush, IIJ, official curmudgeon. My impression is that ISOC makes the IETF look extremely operationally clueful. The ISOC had to go find an operator to play. Why does this smell like colonialization? The operators we do talk to each other. I'll be at AFNOG next week, and whatever it was 2 weeks ago.
Write it. So any ideas you have for things that have tripped you up or tripped folks who work with or around you up that should be documented as BCOPs would be handy to just list down now.
This can also be as simple as, my customers don't know how to use IRR. Wouldn't it be nice if I had a document that described, here's what filtering looks like, here's how to use an IRR, or here's what simple egress looks like, right? Basic things that you might want to hand to something that's a repeatable task that you have to teach over and over again. Wow. Crickets. Mr. Ross.
Brandon Ross, Network Utility Force. One of the things that you sparked my memory for when you just said that was that actually one of the things I deal with a lot of the smaller operators is all of the other stuff besides plugging a router in that you should do or is the best current practice to do for a network. Things like, and you asked for ideas, I'm throwing it out there. Things like you should probably have some sort of out-of-band network so that you can reach your stuff. Things like you should probably have, let's say a IPAM solution, let's say, or a SNMP management system. You'd be surprised, or maybe not everyone, but some people might be surprised by how many small operators didn't even realize, hey, I should go buy a copy of SolarWinds or something to ping my routers every once in a while. So maybe that's something that should be added to the list is, hey, here's kind of a list of things to consider if you're starting an ISP or something like that.
Good feedback. Okay. Rudiger.
Are you or anybody else maintaining a list of documents that are offered and documents that are requested?
It's a wiki, and you're welcome to make changes, suggestions. Yes, we just launched this wiki format exactly for the feedback that you gave at the last meeting, and it is intended to be open and community driven, so feel free to jump in and and submit, make changes, requests, etc. It's community-owned. Yeah, that's bcop.nanog.org. All right, well, if no other feedback, that concludes the BCOP track. Thank you very much for your time, and ciao.